Okay, now that I've almost finished drawing Avenger, minus weight saving and wire, I'm actually thinking I might start drawing another robot. And because if I'm going to get all my steel cut, I'd like to get enough steel cut for 2 robots, that way I can have a sportsman class Avenger type robot. And I also want a spinner, because I haven't had spinners for a long time, and I'd like to build one. And I actually did draw one up. So this one is, this is Fury. It's a horizontal spinner. I almost finished it, and I may build it, may not, I'm not sure yet. There's still quite a few things I want to fix up on it. But I'm thinking I might draw a vertical spinner, because I actually kind of like vertical spinners more. And we'll create a new sketch on the XZ plane. X for forward, Z for upwards. Create a construction circle. And that's roughly what my disk would look like. I think I'll just do a single disk, not a drum or anything like that. I can't really decide if I want a drum or a disk. We'll just do a disk. And I'll make it bigger than Demon. I'll make it 350. Because you've got to be bigger than Demon. And we'll draw another circle out here, which is the wheels, which I'll put towards the back so this thing can be invertible. And they're 100mm wheels. I'll draw a ground line across the bottom, tangential to the wheel. Draw a center line from the center of the wheel to the center of the disc. We will make the wheel 250mm behind the center of the disc for the moment. And come on, I want to put a tension there. Come on, select. There we go. Then we'll give the disc 10mm ground clearance. I can make that shorter. I'll make that 200 just to see. That'll do. So that's a rough layout sideways of the robot. I might just draw another ground line. So that's the ground line if the robot's upside down. And that's the center line. I'm going to do my robot different than the way most people do. Most people put the chassis parallel to the ground and then go up to a disc and wheels out the back and all that sort of rubbish. I'm going to put my chassis in line with the center line between the disc and the wheel, just because I want to. I don't want to copy everybody else. So there's my first sketch, the rough layout of what the robot will look like, and we'll call that vertical layout. And I'll do a plane that's perpendicular to that one on the chassis center line. Turn the visibility off on that. Red plane, chassis center line. What can I do next? Actually, I can draw my disc. We might as well draw a disc in here. I'm going to do a sawtooth disc like on Fury, because I reckon that looks cool. I know it doesn't hit as hard as everybody else, because single tooth hit harder, but I like 8 teeth. Just because I'm stupid. So we put a 46.26. 46.26 millimeters is the outer diameter of a pipe. And I will draw a center line to there, and a center line to there. I will go to my parameters. Come on, parameters, open. Thank you. Add a numeric. No number of saw teeth. I'll make this into a parameter so I can use it later. I'll change it to a unitless parameter. You don't want 8 millimeters of saw teeth, you want 8 saw teeth. So it's unitless, UL, and that's just 8. So 8 UL. 8. And this dimension here, this angle is 360 degrees divided by number of saw teeth, which is 45 degrees. And what else? We'll start drawing it. Okay, that one there is the cutting tooth, which I always make 10 degrees. Can have it sharper, but if it's sharper it'll blunten quicker. And 10 degrees will still give you a single point of impact. When I extrude it, I'm just going to extrude this part in here and then pattern it around the number of teeth times. So I split this arc here just so Inventor is easily able to figure out the interior of this. If you don't split it, sometimes Inventor gets confused. Inventor's not the best sometimes. So then I'm going to create another parameter. Primary plate thickness, 6 millimeters. We might as well do a secondary while we're here. Secondary plate thickness, 3 millimeters. Oops, no, I didn't change to 6. 6 millimeters. Done. Update, save. Save it in the Aggressor folder as revision 05. Skeleton. And then we'll create a part, derive in my skeleton, select my sketch, select the primary plate thickness and the number of saw teeth, do an extrusion, extrude both directions at once, about the center line, symmetric extrusion, extrude at the primary plate thickness. That way it's the disc is the center of the robot. It's on the center plane. It's extruded both directly in the middle of the center. Yeah. Oh, you know what I'm talking about. And we'll do a pattern. We'll pattern that feature. The center of the rotation is the center of this circle, and the number of times is the number of saw teeth. So there's my sawtooth disc. 3.7 kilograms. Might be too heavy. Oh, we'll just leave it, see what happens. And I'm going to make it black. New assembly. copy the disk, copy, copy, copy the disk into the assembly, paste. The disk is inserted onto 0, 0, 0 and it's grounded, so that is currently my robot. Looks kind of good. Sort of, maybe. I don't know yet. Save. There's F0105, otherwise known as Aggressor. We'll go back to skeleton and do some more drawing. Go back to this centerline chassis that we did. I'll rotate it around so I can see what I'm doing. We'll project the center of the disk. That is my hub. You might as well constrain it. These little doohickeys here are where the bearing sits. I remember the bearing is 12 millimeters long. And the outside dimension of the bearing is I've forgotten. I'm pretty slack. What bearings am I using? My bearing. Copy. And copy the bearing out of this model. Instead of searching through the content center, we'll just copy and paste it. Paste. Paste. Open. Change size. I'm not going to change the size, I'm just going to bring up the table with all the dimensions on it, just so I can remind myself. I've got a DN720 series bearing and it's a 32004X, which is the standard size. The shaft diameter of 20 millimeters, outer diameter of 15, total width, no, outer diameter of 42, total width of 15, and the outer bearing width is 12. 20, 42, 15, 12. Okay, done. I'll just save that. Always remember to save. Yep, so that's 12. Oops. Perhaps if I go back into the sketch before I start mucking around. Okay. So the outside of the bearing, whoops, that dimension already is. I'll still be asleep. The outside dimension of the bearing is 42 divided by 2. That's 12 long. And the thickness of the pipe is 3.682. And I can remember that because I'm a boring person. And we'll make the total width of the hub to be we'll make it 60 for the moment. And we need an axle. The length the axle sticks out from the inside of the bearing was 15 plus primary plate thickness. Yes. Okay, there's my disc hub bearing axle assembly. So that's the start of my spinner.